welcome to the Royfit channel. I'm Royston, your host. This is going to be one of the most comprehensive channels on YouTube to do with fitness, biology, and everything in between really. Today's first video is going to be on fats, the type of fats, what are fats, what ones are good or bad, and how much you should eat a day really. Alright, let's get into it. Right, we're going to start off with types of fat, good or bad, and daily intake. Now, fats should take up 20 to 35% of your daily caloric intake. Obviously, that's depending on your diet and your goal, but this is according to the NHS website. Now, what I'm going to be talking about down this list is all modelled from a 2,000 calorie a day diet. Now, obviously, some of these numbers are going to be different if you're eating 2,500, 3,000 calories, 1,800. Right, now as for types of fats, we've got, we'll start off with the bad, we've got saturated fats. Now, what this does is it builds up cholesterol, which is a fatty substance in your arteries. Now, these are also known as low density lipoproteins, or LDLs, you might be aware of them being called. Now, these are obviously carried in the blood, as I just said. Now, eating too much saturated fats in your diet can raise the bad LDL cholesterol in your blood, which actually increases your risk of heart disease and stroke. Now, you should not eat more than 30 grams of saturated fat a day. Again, remember this is out of a 2,000 calorie day intake. Now, when you're looking at labels at the shop, anything more than 5 grams of saturated fats per 100 grams is way too much. Is absolutely way too much. And that is something you should avoid. Obviously, you can eat stuff with saturated fat in, but you always want to make sure it's 1, 2, or 3 grams per 100 grams. Just makes that a little bit of difference. Now, we'll move on to the unsaturated fats. They're known as the good fats. They're actually high density lipoproteins. So you've got your LDLs, which are your bad ones, and you've got your HDL, which are good. Now, your HDL doesn't clog arteries as much. Obviously, there's a limitation to this. Now, HDL is good for cholesterol. It has a positive effect by taking away LDL cholesterol from parts of the body where there's too much of it, all the way to the liver where it can be disposed of. So the more unsaturated fat you have compared to saturated fat, the better. Now again, daily intake based off 2,000 calories. You want around 65 grams of unsaturated fat per day. Now that is over double the amount of saturated fat that you can actually ingest. Obviously, that actually says something. And again, you're out shopping, you're looking at your labels again. More than 17.5 grams of fat per 100 grams is classed as high. Now that is a lot more than the 5 grams of saturated fats per 100 grams for saturated. Now, if you're looking for low fat products, obviously 3 grams of fat or less per 100 grams is classed as low. Anywhere in between, perfectly fine. Now there is a third type of fat, and these are your trans fats. There you go, in brackets there I've put really bad because they are. Now, trans fats are the same as saturated fats, as it will raise LDL and cholesterol, but has a higher affinity to do so, and it's harder for your body to remove. Using a lot of trans fats in food was banned in the UK, so you usually don't find it in many labels, but it does occur naturally. But it's in very small amounts, so you won't even find it on the labels. Now, this is where we get into the heavy kind of facts about what fats are, what makes them up, their structure, where they're used, where they're stored, how much energy you actually get out of fat. Now, a fat molecule consists of 2 parts, a glycerol backbone and 3 fatty acid tails. Now, as you can see here in the diagram here, you've got the backbone and then you've got the tails. So, the glycerol is a small organic molecule with 3 hydroxyl or OH groups. While a fatty acid consists of a long hydrocarbon chain attached to a carboxyl group, a typical fatty acid contains 12 to 18 carbons, though they can be as few as 4 or as many as 36. Now these fatty acids go through a dehydration synthesis reaction, and this basically yields the fat molecule with 3 fatty acid tails and a backbone. Now saturated fatty acid tails are straight, so fat molecules with fully saturated tails can be packed against each other. Now this tight packing results in a solid at room temperature. As you can see here, you've got the backbone and you've got the tail. They all line up nice and smoothly. Now unsaturated fatty acid tails are bent due to the cis double bond. Now this makes it hard for fat molecules with one or more cis unsaturated fatty acid tails to pack tightly together. So these fats usually tend to be liquid at room temperature. As you can see here, it's got a bend right in the middle bond. Now lipids, fats, play a crucial role in our body, even though it's popularly viewed as a negative molecule, and it's very misunderstood. Now I've already spoken about 3 types of fat our body uses, but there's actually 5. So they're the saturated fats, which we already spoke about, labelled as the bad. We've got the unsaturated, found in vegetable oils, nut oils, labelled as the good fats. Again, these are oils because they're liquid at room temperature. And you've got polyunsaturated, which is your omega-3. Now this is found both in plants and animals. It's known to be good for the body and actually reduces the risk of cardiovascular disease, so always get in as much of that as you can. Now we've also got monounsaturated. This again is a plant-based fat, and again it's a good fat. Now lastly, we've got trans fats and hydrogenated fats. These are the factory made or factory processed fats that are bad for you, but again they can be found in very small amounts naturally, again usually missed off labels because of such minute amounts. Now our body breaks down fats in the small intestine by the use of an enzyme called Pancreatic Lipase. This breaks the fats into fatty acids and glycerol. Basically, you know how I spoke about earlier about the glycerol backbone and the fatty acid tails? That basically gets broken up so that they can get stored. Now this process, if you do have a high fat diet, it can take up to 6 hours for your stomach to do this. Yeah, that's the longest digestive process of all of the macronutrients that we eat. Now once it's been digested, it then gets carried via the lymph system and stored as triglycerides, basically just chains of fatty acids. Now these get stored in our cells and around muscles and organs in something called adipocyte tissues. Now they're put there for later use. Now fats are extremely high in energy, carrying up to 9 calories per gram, compared to the 4 calories per gram found in carbs and protein. Fat should make up 20 to 35% of daily intake, as I said at the start. They are used as an energy source during long endurance type activities such as running long distances, repetitive constant movements, or if you're just standing on your feet all day. Now this fat ends up being used the same way as carbohydrates. It gets converted into ATP through a very long, strenuous process. Now as you can see in this picture down here, this is actually a picture of your adipose cells chock full of fat, and this is what it looks like. Now unlike glycogen, which has limited storage in our muscles, so this is sugar, liver fats don't have this problem. If we continually eat fats and not use them, our body will store them indefinitely, even to an unhealthy and unsustainable level. Now it's not only energy that fats are used for, and you're probably aware of this. Fatty acid make up our cell membranes, so the outside shell of cells that holds them together. Phospholipids, to be exact, contributing to 50% of a cell's membrane. Now, the reason our cells actually have this fatty membrane is because it creates a biolayer, an insoluble outer layer and a soluble inner layer. Now, this is due to the fatty head being at the top and the tails being on the inside, and it will be like that inside the cell. And one side repels water, one side likes water. Now, our body needs vitamins to function properly, and some of these are only fat soluble. Now, the vitamins I'm talking about are A, D, E, and K. The good thing is we don't need these vitamins every day, as a large amount can be stored in our adipose tissues. And unlike water-soluble vitamins, they don't break down quickly or need constant replacements. Now, fats are very good thermal insulators. Every single animal alive, whether that be in the ocean, on land, deserts, jungles, us in our concrete jungles, we use them as a thermal insulator. It has been a very consistent thing for living creatures. Now, what it does is it wraps around our organs and muscles to trap in heat, but also gives our organs some protection where bones can't. It's kind of like a soft cushion. Now, not only that, fats can increase the transmission speed of brain signals and neurons. So this is called the Myelin Sheath. Now, it's located on the nerve axon, the primary transmission line of the cells. So in our adipose tissue, you have a lot of blood vessels and nerve endings. So this is so your body can release the fat, release the energy and the hormones that are produced as the moment they are signaled for it. Now, here are some examples of the hormones release. Now, we've got aromatase, which is involved in the sex hormone metabolism. So basically what this does is you have testosterone, you have a lot of free testosterone, say, bouncing around. Aromatase will come along and it will aromatize it into estrogen. Now, this is very important for males, not so much females, since females create estrogen in higher amounts. Now, we've got TNF alpha, IL-6 and leptin. Now, they are involved in message signaling between cells. Now, we've plasminogen activator inhibitor 1, which is actually involved in blood clotting, extremely important. We've got angiotensin, which is involved in blood pressure control, again extremely important. Adiponectin, I really do hope I'm pronouncing these correctly, which improves the body's sensitivity to insulin. So it helps protect you from developing type 2 diabetes, again extremely important. All of these things on here, they have a job for a reason, and you're 15, 20, 25% fat, you're not unhealthy. You're not. You are in a very healthy range. But you have people who want to come all the way down to 8 and 10%. Now, for women, the lowest a woman should go is 12%, because otherwise her hormones can stop working. Men can go all the way down to 6-7% at a push, but again, they're actually not healthy at that stage, because that still messes with all of these hormones. Now, last on this is Lipoprotein Lipase and a polyprotein. Now, these are actually involved in storage and metabolism of fat. You need fat for this one to organize your fat, basically. Now, I do hope that you've learned something today. Obviously, like I said, very comprehensive talk today. All of my videos are going to be roughly similar to this. I'm going to spice it up a bit so you're not just staring at a screen of words all the time. Thank you for watching. Don't forget to subscribe, hit the bell, hit the like button. Thank you for the support.